the silent darkness above your head exists a reality so vast, so overwhelmingly enormous, that if the human brain could truly comprehend its full scale, it might completely collapse under the weight of its own understanding. Right now, wherever you are sitting, maybe in your room, maybe on a busy street, maybe looking out a window at the rising or setting sun, your world feels stable. It feels defined. Your surroundings have edges. Your city has limits. Your country has borders. Even your planet feels unimaginably huge. But what if everything you have ever known, everything humanity has ever built, every mountain, every ocean, every civilization, is not even a meaningful particle in the true structure of the universe? Check, what if the reality we experience daily is just a microscopic layer floating inside an ocean so vast that numbers themselves begin to lose meaning? Tonight, we are beginning a journey that will not only challenge your imagination, it will stretch it beyond the limits it was ever designed to handle. Because the deeper we travel into cosmic scale, the more reality itself begins to feel like fiction. The Earth is over 12,000 kilometers in diameter. From space, it appears as a glowing blue marble wrapped in swirling clouds. Its surface holds continents large enough to contain dozens of nations, oceans deep enough to swallow mountains, and weather systems powerful enough to reshape entire regions. To us, Earth feels like everything. It is our home, our history, our battlefield, our sanctuary. But the first astronauts who saw Earth from orbit experienced something deeply unsettling. Something psychologists now call the overview effect. For the first time in human history, our entire world could be seen at once. No borders, no divisions, just one fragile sphere floating in endless darkness. From that perspective, in every war ever fought, every empire ever built, every person who ever lived, existed within a thin layer of atmosphere, barely thick enough to protect life from the vacuum beyond. Suddenly, Earth did not feel enormous anymore. It felt vulnerable. And yet, in cosmic terms, even this realization is only the beginning. Leaving Earth behind in our imagination, we begin to move outward into a region of space that humanity has only recently learned to explore. At first, the distance does not seem too intimidating. Just beyond our planet lies the Moon, a silent gray companion that has watched over life on Earth for billions of years. The average distance between Earth and the Moon is about 384,000 kilometers. This number sounds enormous. It is far beyond anything humans travel in daily life. Yet when astronauts first made the journey during the Apollo missions, they discovered something surprising. The path between Earth and the Moon is not filled with debris or cosmic chaos. It is almost completely empty. In fact, the emptiness itself becomes the first clue to understanding the true scale of the universe. If you could shrink Earth down to the size of a basketball, the Moon would be about the size of a tennis ball placed roughly 7 meters away. Suddenly, what once felt like a close neighbor becomes distant and isolated. Even more astonishing is the realization that you could line up every single planet in our solar system between Earth and the Moon, and still have space left over. This simple comparison begins to quietly dismantle the comfortable illusion that space is crowded. Instead, it reveals a universe defined not by objects, but by the vast distances separating them. Continuing outward, we encounter the dominant ruler of our cosmic neighborhood, the Sun. At first glance from Earth, it appears as a manageable glowing disk in the sky. But this perception is dangerously misleading. The Sun is not just large, it is almost incomprehensibly massive. With a diameter of nearly 1.4 million kilometers, it could contain more than 1 million Earths inside its fiery volume. Its gravity anchors the entire solar system, bending the paths of planets, comets, and asteroids into elegant elliptical orbits. The Sun is a nuclear furnace, converting hydrogen into helium every second and releasing more energy in a moment than humanity has produced in all of history. Yet perhaps the most unsettling truth about our star is not its size or power, but its ordinariness. Across the galaxy, there are stars far larger, hotter, brighter, and more violent. Some are so massive that if they replaced our Sun, their surfaces would extend beyond the orbit of Mars or even Jupiter. Others spin so rapidly or collapse so violently that they warp the very fabric of space and time. In this wider context, our Sun is simply average, one among hundreds of billions. As we continue our journey, we pass the orbits of the inner planets, Mercury racing around the Sun in just 88 days, Venus wrapped in toxic clouds of crushing pressure, and Mars with its frozen deserts and ancient riverbeds hinting at a lost past. These worlds feel like stepping stones in a vast cosmic sea. But beyond them lies a region that further challenges our intuition, the asteroid belt. Contrary to popular belief, this belt is not a dense minefield like those shown in science fiction movies. The asteroids are separated by distances so great that a spacecraft can pass through without ever coming close to a collision. Once again, emptiness dominates. Moving even farther outward, the gas giants emerge. Jupiter, a colossal storm-racked world larger than all other planets combined, and Saturn, encircled by rings so delicate and wide they seem almost unreal. Uranus spins on its side like a toppled giant, while Neptune howls with supersonic winds in the darkness. These planets mark the visible frontier of the solar system as most people imagine it. Yet the truth is far more complex. Beyond Neptune stretches the Kuiper Belt, a distant halo of icy remnants left over from planetary formation. Here, dwarf planets like Pluto drift in slow, cold orbits. Sunlight at this distance is so faint that it resembles twilight on Earth. Temperatures plunge to unimaginable lows. And still, even here, we have not reached the true boundary of the Sun's influence. Far beyond what any telescope can directly observe lies the hypothetical Oort cloud, a vast spherical swarm of cometary bodies extending perhaps 50,000 astronomical units from the Sun. If this cloud truly exists, as scientists believe, it represents the ultimate frontier of our star's gravitational reach. At such distances, the Sun itself would appear as just another bright star in the sky. The warmth and familiarity of our home system would fade into anonymity. Perhaps nothing illustrates the scale of this region better than the journeys of humanity's robotic explorers. The Voyager spacecraft, launched in the late 20th century, have been traveling outward for decades. Despite moving at incredible speeds, they have only recently begun to enter interstellar space. The signals they send take many hours to reach Earth. Their tiny transmitters whisper across billions of kilometers of silence, carrying messages from a civilization that may one day vanish long before the probes reach their final destinations. In this growing darkness, one realization becomes impossible to ignore. The solar system is not a tight cluster of worlds circling a friendly star. It is an immense, sparsely populated region where distance is the defining feature. If Earth were reduced to the size of a grain of sand, the edge of the Oort cloud might lie kilometers away. Imagine walking across a vast desert where every step represents millions of kilometers, and every object you encounter is separated by emptiness that stretches beyond the horizon. This is the true architecture of our cosmic home. And yet, as enormous as the solar system appears from within, it is still only a tiny island in a much greater ocean. Because soon, we will confront the next mind-breaking leap in scale, the distance to the nearest star. As we slowly leave behind the fading influence of the sun, something strange begins to happen to our sense of reality. For millions of years, every object humanity had ever known existed within the gravitational comfort of our solar system. The planets moved in predictable patterns. The sun dominated the sky. Even the distant Kuiper belt still felt like part of our cosmic neighborhood. But once we cross into interstellar space, that familiarity vanishes completely. We are no longer traveling between worlds. We are traveling between stars. And this is where the true scale of the universe begins to break the human mind. The nearest known star system to Earth is Proxima Centauri, a faint red dwarf star that belongs to the Alpha Centauri system. On paper, its distance seems manageable, about 4.24 light-years away. But the moment we try to translate that number into human experience, the illusion collapses. A light-year is not just a measurement of distance. It is the distance light itself travels in one entire year, moving at nearly 300,000 kilometers per second. In a single second, light can circle Earth more than 7 times. And yet, even at this impossible speed, it takes over 4 years to reach the nearest star. To understand how enormous this truly is, imagine shrinking our entire solar system so that the orbit of Neptune fits inside a small coin. At that scale, the nearest star would still be hundreds of kilometers away. Suddenly, the comforting image of stars scattered closely across the night sky is revealed as an illusion of perspective. They are not nearby lights decorating a cosmic ceiling. They are distant suns separated by unimaginable gulfs of emptiness. Human technology, impressive as it may seem, is almost laughably slow on this scale. The fastest spacecraft ever launched from Earth would require tens of thousands of years to reach Proxima Centauri. Entire civilizations could rise and fall, while such a vessel drifted silently through darkness. And even if we developed propulsion systems capable of traveling at a significant fraction of the speed of light, the journey would still take years or decades. Interstellar travel is not simply difficult. It fundamentally challenges the limits of physics, engineering, and perhaps even human lifespan. Yet stars themselves are not static beacons. They move. They orbit the center of the galaxy, passing through regions of varying density and gravitational influence. Over millions of years, the constellations we recognize today will distort and dissolve. New stars will enter our neighborhood while others drift away. The night sky is not permanent. It is a dynamic and ever-changing landscape shaped by forces far beyond human control. Between these stars lies the interstellar medium, a tenuous mixture of gas, dust, magnetic fields, and high-energy particles. Though incredibly sparse compared to Earth's atmosphere, this medium plays a crucial role in the life cycle of galaxies. Within cold molecular clouds, gravity slowly pulls matter together until new stars ignite in brilliant bursts of nuclear fusion. Elsewhere, the violent deaths of massive stars scatter heavy elements across space, seeding future generations of planets and possibly life. In this way, interstellar space is not merely empty. It is the birthplace and graveyard of cosmic evolution. But perhaps the most unsettling realization is how invisible our own solar system becomes at these distances. From even a few light-years away, the sun would appear as just another point of light among countless others. Earth would be completely undetectable with ordinary observation. Every human achievement, every piece of art, every signal ever broadcast into space would vanish into statistical noise. The idea that we are central to the universe becomes impossible to sustain. And yet, despite this overwhelming insignificance, humanity continues to dream of reaching the stars. Scientists propose concepts like generation ships, cryogenic sleep, and laser-driven light sails, bold attempts to bridge the cosmic void. These ideas reveal something profound about our species. We are not content to remain confined to a single world. Even when faced with distances that dwarf imagination, we still feel compelled to explore. As our journey continues, another startling truth emerges. Individual stars, vast as they may seem, are themselves only minor components of something far larger. When we step back far enough, the countless points of light that fill the night sky merge into a single breathtaking structure, the galaxy. And it is within this next scale that the universe begins to feel truly infinite. After traveling across interstellar darkness, after realizing that even the nearest stars are separated by distances that can consume entire civilizations, we now reach a scale where individual suns begin to lose their identity. From far enough away, the countless stars that once filled the night sky merge into a glowing river of light. A vast spiral structure rotating silently through cosmic time. This is the Milky Way galaxy, our true cosmic home. Stretching across nearly 100,000 light years, the Milky Way is not just a collection of stars. It is a gravitational ecosystem containing hundreds of billions of stellar systems. These are massive clouds of gas and dust, invisible halos of dark matter, and at its very center, a supermassive black hole with a mass millions of times greater than our Sun. Around this galactic core, entire star systems orbit in slow, majestic paths that take hundreds of millions of years to complete. When our solar system last occupied its current position in the galaxy, dinosaurs had only just begun to walk the Earth. From this perspective, human history becomes almost unimaginably brief. All recorded civilization has unfolded within a fraction of a single galactic rotation. Empires that once seemed eternal are reduced to fleeting moments in a cosmic dance that has continued for billions of years. The scale is so vast that even the idea of permanence begins to dissolve. Stars are born, shine, and die. Galaxies collide and merge. Structures that appear stable today will be transformed beyond recognition in the distant future. And yet the Milky Way itself is not alone. As we zoom out even further, we discover that galaxies form families, gravitational communities known as galaxy groups. Our local group contains more than 50 galaxies, each drifting through space while bound by mutual attraction. Among them is the Andromeda Galaxy, a spiral giant even larger than our own. Currently racing toward us at hundreds of thousands of kilometers per hour, Andromeda will eventually collide with the Milky Way in a titanic event that will reshape both systems. Though the stars within them are unlikely to physically collide due to immense separation, the overall structure of our cosmic neighborhood will be forever altered. But even galaxy groups are only small pieces of an even greater architecture. Clusters of galaxies assemble into enormous structures spanning millions of light years. These clusters, in turn, form superclusters, titanic regions containing tens of thousands of galaxies connected by the mysterious influence of dark matter. Scientists have mapped one such structure known as Laniakea, a supercluster so vast that it defies intuitive understanding. Our entire local group, including the Milky Way, drifts along invisible gravitational currents toward a distant region known as the Great Attractor. At the largest observable scales, the universe reveals its most astonishing feature: the cosmic web. Galaxies are not distributed randomly. Instead, They trace out immense filaments of matter stretching across space like glowing threads in an unimaginable tapestry. Between these filaments lie vast cosmic voids, regions so empty that a spacecraft traveling through them might never encounter another galaxy for hundreds of millions of light years. From a distance, this structure resembles a neural network or the branching patterns of living organisms, leading some scientists to wonder whether the universe itself operates according to deeper underlying principles we have yet to uncover. Eventually, we reach the limit of what can be seen, the observable universe. This spherical region, nearly 93 billion light-years in diameter, represents the portion of reality whose light has had time to reach us since the beginning of cosmic expansion. Beyond this horizon lies mystery. There may be infinitely more galaxies, entirely different physical conditions, or structures so large they challenge our current understanding of cosmology. Because space itself is expanding, some regions of the universe are receding from us faster than the speed of light, forever beyond our reach. This realization introduces a profound philosophical tension. If the universe is truly infinite, then somewhere beyond our observable horizon, there may exist exact copies of our galaxy, our planet, or even ourselves. Every possible configuration of matter could be repeated endlessly across the cosmic expanse. The idea is both awe-inspiring and deeply unsettling. It forces us to confront the possibility that our existence, while meaningful to us, may be only one small variation in an infinite cosmic story. Time adds yet another layer of complexity to this already overwhelming scale. When astronomers observe distant galaxies, they are looking back billions of years into the past. Some of the light reaching our telescopes today began its journey before Earth even formed. This means the universe we perceive is not the universe as it currently exists, but a mosaic of ancient moments stitched together by the finite speed of light. Stars we admire in the night sky may have already exploded. Entire civilizations, if they ever arose elsewhere, may have flourished and vanished without leaving any detectable trace. Space is not just vast. It is a time machine revealing the history of existence itself. And yet, after confronting distances that shatter imagination, after witnessing structures that dwarf comprehension, we arrive at a strangely comforting truth. On a tiny world orbiting an ordinary star in a quiet region of a spiral galaxy, intelligent life has emerged capable of understanding all of this. Humans are made of atoms forged in stellar furnaces billions of years ago. The calcium in our bones, the iron in our blood, the oxygen we breathe, all were born in the hearts of ancient stars. In a very real sense, the universe has become conscious of itself through us. Perhaps the true scale of the universe is not meant to make us feel insignificant. Perhaps it is meant to inspire humility, curiosity, and wonder. Because even though we are physically small, our ability to question reality gives us a unique place in the cosmic story. We may never reach the edge of the universe. We may never fully understand its origin or ultimate fate. But the act of exploration itself is one of the most powerful expressions of intelligence. So the next time you look up at the night sky, remember that you are not just observing distant lights. You are witnessing a vast interconnected system stretching across billions of years and trillions of kilometers. You are seeing the echoes of creation. You are standing at the center of your own observable universe, a fragile point of awareness surrounded by infinite mystery. If this journey through the true scale of the universe expanded your mind, challenged your perception, or filled you with cosmic wonder, make sure you subscribe and continue exploring these mysteries with us. Because this is only the beginning. There are black holes that bend time, galaxies that defy physics, and cosmic phenomena so strange they sound like science fiction. Somewhere out there, in the endless darkness beyond our current understanding, the next great discovery is waiting. And together, we will find it.